Hey everybody, I hope you all are doing well. So today we'll dive into the February-March 2024 0620/42 theory paper, which is the latest paper tested in the February-March examination series. And it is mandatory to do this paper before appearing in your May-June 2024 examination if you want to maximize your practice, because this will give you an idea of how Cambridge is going to test you this time, right? Since it's the latest paper. So without wasting time, I'll just write my name down, which is Suleiman Khan. Can, like the Britishers say, because we're giving Cambridge papers. And we're going to start off with the first question. So the first question says, iron ore contains iron 3 oxide. What is iron ore, by the way? Iron ore is hematite, right? So hematite contains iron 3 oxide, and a blast furnace is used to extract iron from its ore. Equations of some of the reactions. So it's given us certain equations. We know that, what these equations are if you have studied blast furnace properly, if you studied the extraction of iron from hematite properly. What are these equations? Basically, when you have this apparatus of blast furnace, we add coke, we add our hematite, which is essentially Fe2O3, and we add our beautiful calcium carbonate, which is limestone or marble chips. And what this coke does is, and we pump hot air into the apparatus. So what this coke does is it reacts with this hot air to give you carbon dioxide, and this is a highly exothermic reaction. And because this is a highly exothermic reaction, this is going to produce a lot of heat. It's going to produce a lot of heat. And why do we need to produce a lot of heat? Because we want to thermally decompose this calcium carbonate into calcium oxide and carbon dioxide. You know that thermal decomposition is the breakdown of substances by providing heat. So where does this heat come from? It comes from this equation number 1. So this equation number produces the heat, which is used by this calcium carbonate to thermally decompose down into calcium oxide and carbon dioxide. And this calcium oxide then reacts with the silicon oxide, which is present as an impurity in the hematite, because hematite is an ore, right? So obviously certain sand or other materials like SiO2, which is essentially your sand, are attached to it, right? So calcium oxide, because it's basic, and silicon oxide, because it's acidic, they're going to undergo an acid-base reaction to give you calcium silicate, which in layman terms, in the common name for calcium silicate is slag, right? And there's two equations that he's missed. This carbon dioxide, when it is produced, it is further reduced by coke to give you carbon monoxide, and then this carbon monoxide basically reduces the iron from the iron oxide to give you iron and carbon dioxide, right? So it reduces the iron oxide to give you iron and carbon dioxide, and that's how you obtain your iron using the entire apparatus of blast furnace. So it says equation 1 shows the combustion of carbon in blast furnace. Great, we know it shows that. It says name the substance which provides the carbon for this reaction. So what is this carbon called? That's basically your coke, right? So coke is that substance which is providing us with the carbon. It says state the purpose of the combustion of carbon in the blast furnace. Well, obviously I explained it's a highly exothermic reaction, produces heat, provides us with heat. And what is this heat needed for? To break down or to thermally decompose this calcium carbonate. So we say that it is used to produce or to provide heat. And why do we need heat? To thermally decompose. This is just explanation in the bracket, right? You don't need to write this in your answer. To thermally decompose the calcium carbonate. That's it. Now it says iron 3 oxide in iron ore is converted to iron when it reacts with carbon monoxide in the blast furnace. Calculate the percentage of mass by mass of iron in iron 3 oxide. How do you calculate percentages? We take the part and we divide by the whole mass of this molecule, and we multiply it by 100 molecule. Yeah. So what's the part mass? Part is basically the mass which we want to find, which is the mass of iron. So let's calculate the mass of iron. Iron in the periodic table is 56, and since you have 2 irons, you times it by 2. Oxygen is 16, and since you have 3 O's, you times it by 3. If we calculate this, this is going to give me 160, right? So if we check the mass of iron, that's our part, which is 56 times 2, that gives me 112, right? And divided by the entire mass of this compound, which is 160, and you times it by 100% to give you the percentage by mass of iron, that gives me 70%, and I'll write 70 right here. Now it says, state the name of the iron ore, which consists mainly of iron oxide. So what's the name of the ore? Obviously, the ore is called hematite. So it's hematite. right? And aluminum's ore is called bauxite. And if you guys confuse hematite and bauxite, it's very easy to remember it. See, your blood, if you studied biology, you know that the red blood cells contain hemoglobin, and hemoglobin has iron and a protein. So heme basically stands for iron, right? So that's how you could remember it. Describe how carbon monoxide is formed in the blast furnace. How is carbon monoxide formed? Right here. Carbon dioxide is reduced by coke to form carbon monoxide, right? So how do we say it? We say by the reduction of carbon dioxide. And how is carbon dioxide reduced? By coke, right? So by the reduction of carbon dioxide by what? By coke. Write the symbol equation to show the reaction that occurs when iron 3 oxide is converted into iron. So we know that Fe2O3, that's my iron 3 oxide, it is reduced by carbon monoxide to give you iron and carbon dioxide. Now let's balance the equation, because it's a 2-mark question, 1 mark for writing the equation and the other mark for balancing it. You have 2 atoms of iron on the left, you only have 1 here, so you times this by 2. That's great. And now if you check this out, you're gonna balance the other part with trial and error. You know that the number of carbons here, you have 1 carbon here and 1 carbon here. So whatever coefficient I write here, I will have to write the same coefficient here as well, right, in order to make sure that the carbons are balanced on both ends. So I'm going to perform trial and error. I'll first add 1 and 1 here and check whether everything is balanced. So if you check this out, the oxygens are still not balanced. You have 4 oxygens on the left and you only have 2 oxygens on the right, so you can't insert 1. Then I'm going to insert 2 and 2 here. Let's insert 2 and 2. You have 2 times 2, that's 2 O's and plus 3. You have 5 O's on the left and you only have 4 O's on the right. So again, it's not balanced. Then I'm going to insert 3. So if you insert 3, now you will notice that it's a balanced equation. 3 times 1 plus 3. You have 6 O's on the left and you have 3 times 2, 6 O's on the right. And now it's a balanced equation. Obviously, the concept of balancing equations, balancing redox equations with the help of oxidation states is not in your course. You learn that in A-levels. That's why we just have to perform trial and error, or hit and trial jisko kehte hain, in which you need to have the idea that, okay, the carbons on the left and the right are equal. So whatever number I insert, they must be equal. Whatever coefficient I insert, they must be equal for both sides. And that is how our trial and error will help us balance this equation. Now it says, name the chemical process which happens to iron when iron 3 oxide is converted into iron. What is happening to iron 3 oxide? What is happening? The iron 3 oxide is being reduced. So the chemical process is reduction. The carbon monoxide reduces the iron in iron 3 oxide, right? So what happens to the iron in iron 3 oxide? It is reduced. That's why the process is reduction. State the type of reaction by equation 2. So if you check this equation 2, equation 2, that's right here. It's thermally, the calcium carbonate thermally decomposes to form calcium oxide and carbon dioxide. Therefore, the type of reaction is thermal decomposition. Thermal decomposition. Done, peeps? Moving on. It says, explain why the reaction in equation 3 can be described as acid-base reaction. Well, obviously it can be described as acid-base reaction because calcium oxide is basic, silicon oxide is acidic. That's why an acid-base reaction takes place. So we say that calcium oxide is basic, silicon 4 oxide is acidic, and therefore acid-base reaction takes place. Done? Now it says, state the chemical name of silicon oxide. What's the chemical name? I've been saying it all along. It's called silicon 4 oxide. That's the chemical name, yeah? The common name given to calcium silicate, CaSiO3, when it is formed in the blast furnace. What's the common name? That's slag. It's used to make like glass and all of that good stuff. Now it says, aluminum cannot be extracted from its ore using a blast furnace. What's aluminum's ore called? It's called bauxite, right? So why can't aluminum be extracted? Well, because aluminum is above carbon in the reactivity series, meaning it is more reactive than carbon. So the carbon cannot reduce the aluminum oxide to give you aluminum, right? So what do we say? Well, obviously the only reason blast furnace works for iron is because iron is below carbon in the reactivity series. So carbon can reduce the iron oxide to give you iron. Here it can't do so. Why? Because aluminum is above carbon in the reactivity, or you could say it is more reactive than carbon in the reactivity series, or I could also say it's more reactive than carbon. Done. Now it says name the process used to extract aluminum from its ore. What's the process called? That's why we perform electrolysis. We perform electrolysis, right? Molten aluminum oxide, and we add cryolite to it, all of that good stuff. Both iron 3 oxide and aluminum oxide contain metal ions with a 3+ charge. Write the electronic configuration of the aluminum 3+ ion. So if we write down the protons in the nucleon number, the proton number of aluminum is 13, nucleon is 27, right? We know that the number of protons never change. They will still remain 13 for eternity. Why? Because that's the identity card number. Protons are not gained or lost, right? The charges are due to the loss or gain of electrons. So if electrons are lost, there's a positive charge. If electrons are gained, there's a negative charge. So if for a neutral atom of aluminum, you would have 13 protons and 13 electrons, but now it has a 3+ charge, which means that 3 electrons have been lost. So in total now you have 10 electrons. An electronic configuration refers to the distribution of electrons in shells, right? So how are they distributed? The first shell can hold up to a maximum of 2 electrons, so you're going to add 2, and the second shell can hold up to a maximum of 8 electrons, and you only have 8 left. Those of you who can't apply logic, you can also apply mathematics, right? So 13 protons means you're going to have a +13 charge. We don't know the number of electrons, but we know the overall charge is +3. So E is equal to this 3 shifts here, this E shifts there, E is equal to 10. So you have 10 electrons, right? You could also perform simple mathematical equations. Now for iron 3+, let's write that down. Iron 3+ is basically like, if I'm not wrong, it's 2656, right? Yeah, so it's 2656, which means how many protons are there going to be? Protons never change, so proton number are going to still remain 26. If you can't find the number of electrons, well, logically you should have thought to yourself, 3+ means that 3 electrons have been lost. So if for a neutral atom you had 26 protons and 26 electrons, now you would only have 23 electrons. But if you can't apply logic, you could simply say, okay, 26 protons means that you're going to have a 26 positive charge in the nucleus. You don't know the number of electrons, but you know the overall charge is +3. So E is equal to 23. You could also apply mathematics, right? So pretty easy. Moving on, question number 2. Question number 2 says the elements of group 7 of the periodic table are known as halogens. Obviously, why are they known as halogens? Because halogens basically mean, halo means salt, gens mean maker. So they're basically salt makers, right? And they can form halide ions. So identify the halogen with the lowest density at room temperature and pressure. So we know that as you go down the group, the density increases. You all need to know, as you go down the group, the density increases. And you don't need to know the why, but you can use logic. The why you learn in A levels, but you can also use your logic, that is, you're literally going from a gaseous state to a solid state. You know, fluorine, chlorine are gases, then bromine is a red-brown liquid, and then iodine is a solid, and so on and so forth. So solids have a greater density compared to gases, right? That's why the density increases as you go down the group. And why does it increase? That's not in your course, because of increased van der Waals forces or intermolecular force of attraction, but who cares, right? So it says, which one would have the lowest density? Obviously, the element which would be at the top of the group 7, which is essentially your fluorine. Yes. State the appearance of bromine at room temperature and pressure. So bromine is a red-brown liquid. That's its appearance. Appearance also includes the state, right? Use the periodic table to give the symbol of halogen with the highest atomic number. What do we mean by atomic number? Atomic number is literally the proton number. And proton number, what does the proton number mean? The proton number means the total number of protons in the nucleus of an atom. So which halogen has the maximum, the highest total number of protons in the nucleus of an atom? You can check of its atom, right? So you can check this down. Fluorine has 9 protons, chlorine has 17, bromine has 35, this has 53, this has 85. Tennessine actually has the highest number of proton, which means it has the highest atomic number, which is 117. So my answer should be, deduce the number, give the symbol of the halogen. So we have to give the symbol, not the name. So it's a capital T with a small s. You can also give the name. Examiner gives you the mark for it, but it's good to follow instructions if you want to achieve a distinction, right? It says, deduce the number of occupied electron shells in this atom of this element, right? So if we want to check out the shells, you have to check the period number, because the period number tells us the number of shells in that atom, right? And how do you check the period number? Well, the periods are basically the horizontal rows in the periodic table. That's my row number 1. We have to check tennessine, right? That's my row number 1. That's row number 2, 3, 4, 5, 6, 7 right here. So tennessine, since it's in row 7, we are going to say it's in period 7, and period 7 means it's going to have how many shells? How many electron shells? 7 electron shells. Done. Why? Because in period 7. That's for you guys. Done. Now it says bromine molecules have covalent bonding. Okay, great. We know it has covalent bonding, non-metal bonding. What is covalent bonding? Covalent bonding is a sharing of a pair of electrons between two atoms of non-metals, right? So it says, what is meant by a covalent bond? Covalent bond is a pair of electrons, is a pair of electrons shared between two atoms, right? So when a pair of electrons is shared between two atoms, not is, when a pair of electrons. That's better English. So when a pair of electrons are shared between two atoms, and you can write it in the bracket of non-metals, right? But it's just asking us covalent bond, not covalent bonding. Great. So now it says name one halide ion which bromine molecules can displace. Now bromine molecules are going to displace which halide ion will bromine molecules displace? Obviously bromine molecules will displace those halide ions from which it is more reactive. So bromine will displace iodine, astatine, tennessine. Why? Because bromine is more reactive than iodine, tennessine or astatine. That's why it can displace it. And what is a displacement reaction of halogens? Well, a more reactive halogen displaces the less reactive halide from its salt solution. So halide ion, we have to displace the negative ion, right? So name one halide ion. He's also telling you, don't write iodine, write iodide. It's the ion, astatide, tennesside. So it can displace all of them, right? Any three. So any of the three. So it can displace the iodide ion, D-I-D-E, iodide. It can displace like your astatide, T-I-T, aster, T-I-D-E, and it can displace tennesside. And why can it displace it? Because they are less reactive than bromine, right? Or you could say bromine is more reactive. You can add either or. Now explain why bromine can displace the halide ion. Again, because bromine is more reactive. How do we know? Reactivity of group 7s decreases down the group. Bromine is more reactive than iodine, or you could say tennessine, or you could say astatine, or you could say tennessine. And one other reasoning to it would have been that bromine is a stronger oxidizing agent than iodine, but you learn more on that in your A levels. Name a halide compound which can be used to detect the presence of water. So it's basically asking you for the test of water. What are the tests for water? Which two substances can you use? You can either use anhydrous copper sulfate, or you could use anhydrous cobalt chloride. Now it's saying it is a halide compound, which means it has the group 7 ion. So group 7 ion is in copper chloride, not in cobalt chloride, not in copper sulfate. So we have to use anhydrous. We have to name it, right? So anhydrous cobalt 2 chloride. 2 is basically the oxidation state. That's why the formula is COCl2. Calcium chloride is an ionic compound, and he wants us to write the charges, right? So if you talk about calcium and if you talk about Cl, calcium is in group 2, so it's going to lose 2 electrons because it has 2 electrons in its outermost shell. It's going to lose 2 electrons, and chlorine, because it's in group 7, it's going to gain 1 electron forming the chloride ion, and it's going to gain the other electron from the calcium ion, from the calcium atom, and it's going to make another chloride ion. So that's the ionic bonding that's going to take place. For one calcium 2+, you need to have 2 chloride ions, right? And and the electronic configuration, to write the electronic configuration, you need to know the number of protons and electrons in a neutral atom. So in a neutral atom, calcium basically has 20 protons and 20 electrons, and chlorine has 17 protons and 17 electrons. Now that calcium is a 2+ ion, now you only have 18 electrons, and chlorine, because now it's a negative ion, it's the chloride ion, it has gained an electron, so now it also has 18 electrons. So we have to be sure here. So calcium will make a 2+ ion. Sorry, this is not calcium, this is Cl. So calcium will make a 2+ ion, Cl will make a 1- ion, Cl will make a 1- ion, right? And then you literally just draw the shells, which are the electrons of shells, which are you literally draw the shells and the electrons which remain in those shells. So chlorine, it will now have 18 electrons. So it already was in group 7, so it had 7 electrons in its outermost shell, and it gained 1 electron from the calcium atom, right? So once it gained an electron, we are going to, because we are representing calcium's electrons with a cross, we are also going to represent this with a cross. Boom shakalaka. And similar is the case here. It already had 7 electrons, 2, 4, 5, 6, 7, and it gained an electron from the calcium atom. Therefore, we are going to represent it with a cross. And calcium, how many electrons does it have? 2 and 8. So 10 are already shown. You have to show 8 more. So 2, 4, 6, 8. You can draw this with a compass, right? My circles aren't that good. Compass is not necessary, but my circles aren't that good. Okay. Aqueous lead ions are added. Aqueous lead ions are added to aqueous chloride ions, a white precipitate of insoluble lead 2 chloride. A white precipitate of insoluble lead 2 chloride is formed. Well, obviously, you have the lead ions. So if I draw a beaker right here, you have the lead 2+ ions, and you are adding it to the chloride ions, right? Again, a precipitate would form, and this reaction is called a precipitation reaction because lead chloride is insoluble. Only that is the reason why the white precipitate is forming, because lead chloride is insoluble salt. Now saying, name a lead compound which can be used in this reaction. Well, obviously you have to use a soluble salt of lead. Remember, whenever we make insoluble salts, what do? We take 2 soluble salts of each compound that we are given. So we take a soluble salt of lead, which is lead nitrate, and we take a soluble salt of Cl. There are a lot of soluble salts of Cl. So name lead compound, which is basically lead 2 nitrate, because all nitrates are soluble. You can't take lead sulfate. Lead sulfate is insoluble, right? And it says, write the ionic equation for this reaction, include the state symbol. Ionic equation basically means the change. So what's the change? It does not have any spectator ions in it, right? We don't write the spectator ions in ionic equation, which basically means you are writing the change. So what's the change? The lead 2+ ions bonded with 2 chloride ions to give you PbCl2. Those of you who don't know, understand what to write here, remember the charges should always be equal. For a 2+ ion, you need to have 2 minuses. So if you have a 2+ ion, chloride is only 1 minus. How many more minuses do you need? 1 more. That's why we wrote 2Cl minuses. What are the state symbols? Because this is ions, they're going to have aqueous state symbols, and lead chloride is solid. That's why, because it's insoluble, right? So it's solid. That's why it'll have a state symbol of S. That says, name one other insoluble chloride. Well, insoluble chloride, we've studied our solubility rules. All group 7s are soluble except for LMS. All chlorides are soluble except for LMS. Lead, mercury, silver. So you could write either or, right? So you could write silver chloride, or you could also write mercury chloride. Mercury 1 chloride. Done and dusted. 18 marks. Gali. Question number 3 says, the question is about acid, bases, and alkalis. So if you check this out, you're given pHs. This is 14 pH, which means it's a strong base. 10 pH means it's a base, but it's relatively weaker compared to sodium hydroxide. But again, it's a base, right? Or you could also call it an alkali, because alkalis are soluble bases. You can also call it alkali because they are dissolving in water. So soluble bases are called alkalis. Now, H2O is neutral. Yeah, and 4 and 1. So pH 4 and pH 1 both mean that they are acids. Both mean they are acids, but pH 4 means it's a weak acid. See, it's an organic acid. It's basically your vinegar, ethanoic acid. And this is a strong acid because it has a pH of 1. All right. That says, define the term base. What is base? Base is a proton acceptor. So any substance which is a proton acceptor, or that is a proton acceptor. That is a proton acceptor. What is meant by the term alkali? Alkalis are soluble bases, and bases are usually metal oxides, metal hydroxides. So you could also define it as soluble metal oxides and hydroxides, but it's better to just say soluble bases. Now, thymolphthalein is an indicator. What is the color? So thymolphthalein will give you a blue color in a base, and it's going to give you it's going to be colorless in an acid. Sodium hydroxide is a base, so it's going to give me a blue color. It's a very strong base, and in an acid it's going to be colorless, right? Now it says use the information in 3.1 to identify which substance will have the highest concentration of H plus ions. The substance which is the most acidic will have the highest concentration of H plus ions. And how will we know which substance is most acidic using the table? Because the most acidic will have the lowest pH. So the substance with the lowest pH will have the most number of H plus ions because it's a strong acid, and we know strong acid fully ionizes in aqueous solutions, right? So which substance will have the strongest, the greatest number of the highest concentration of H plus ions? It's going to be HNO3 aqueous, and the explanation to it is what? It has the lowest pH, because it's saying use the information in table 1, so table 3.1, sorry. So 3.1, how did we come to this conclusion? Because in table 3.1 you had the lowest pH of nitric acid. It says name an indicator which can be used to identify the substance with highest concentration of H plus ions. Well, which indicator do we use? We use universal indicator. Now, you could also represent it with the UI, right? But universal indicator, because some of you guys might think, sir, why can't we use a simple indicator like methyl orange, thymolphthalein, or something like that? Well, the reason for that you learn later on in A levels. There are a lot of reasonings that you learn in A levels, but you need to understand that indicators such as thymolphthalein, methyl orange, and all of these in phenolphthalein, bromothiamyl blue, they are all made for a specific pH. Whereas a universal indicator, they will all work in a particular range of pH, but whereas a universal indicator works for a wide range of pHs. That's why you could use universal indicator paper everywhere, right? A universal indicator. But just and you could think about this, this question as science students should have come to your brains at some point in time. Okay, if an indicator gives me one color in a base, one color in an acid, why do we need to have so many multiple indicators? Because you need to understand that they operate in a range of pHs, in a very small range of pH, whereas a universal indicator has a wide range of pH. That's why we use a universal indicator. Complete the equation to show the dissociation of ethanoic acid in aqueous solution. He's already given us ethanoic acid. You are going to represent it with a reversible sign. Why? Because it partially dissociates. To show partial dissociation, we use a reversible sign. The H plus ion is going to be there in the solution, and this ethanoate ion is going to be my negative anion, right? So this is going to be my anion, and the H plus ion is the ion which makes it into which gives it its acidic properties, and they're obviously aqueous, and they're ions, right? So ions are aqueous. Write an ionic equation which represents the neutralization reaction between any acid and any alkali. So any acid base neutralization reaction is H plus OH minus gives me H2O. And because you have to write this, it's not asking for the state symbols, but you know that they are ions, so these are aqueuses, and H2O is a liquid. And if you don't trust me, you can literally just take sodium hydroxide and you react it with HCl to give you NaCl plus H2O, and NaCl is aqueous, right? So you could write this equation and try to eliminate the spectator ions out of it. You will end up with this particular equation right here. Use any alkali, any acid, you will end up the final result, and eliminate the spectator ions. The final result will be this, right? Then this is basically rough work, yeah. It's your rough work if you don't understand this. Okay, it says dilute nitric acid reacts with this. It's basically a titration reaction. That's great, amazing. It says use the following, calculate the concentration of HNO3, and you're given a known concentration. So titration is going to take place finding the concentration of an unknown solution with the help of a known solution. See, it's very easy. We're going to use N is equal to CV to find the number of moles of calcium hydroxide. Somebody's calling me. Okay, no. So you're going to use N is equal to Cv to find the number of moles of calcium hydroxide right here. Then we're going to use our equation to find the moles of HNO3 that form. And then we have the volume of HNO3. So you're going to use N is equal to Cv again to find the concentration of HNO3, which is nitric acid. So here we want to find the moles of known data. We use the equation to go from the known data to the unknown data. And in the end, we find the concentration. So I'm going to do it in this particular area right here, and then we're going to move them in their particular places, because they can sometimes they cannot give you they sometimes don't give you the steps for it, right? So you have to do it in one go. So let's do it. The first equation is N is equal to Cv. We have to find the moles. You're given the volume and the concentration. So what are the moles of calcium hydroxide? Concentration is 0.0150, and you have the volume, which is 20 centimeter cube. Remember, these two should always be the same unit. So if this is decimeter cube, if this is decimeter cube, this should also be decimeter cube. So what am I going to do? I'm going to divide 20 by 1,000. So divide 20 by 1,000. That gives me 0.02. So 20 divided by 1,000, right? So 0.02. N is equal to, what does that give me? N equals 3 into 10 raised to the power minus 4 moles. Done. Once you find the moles of calcium hydroxide, then we use the equation to find the moles of HNO3. So what is the equation? The equation is telling us that for 1 mole of calcium hydroxide, it always reacts with 2 moles of nitric acid. So 1 mole of calcium hydroxide always react with 2 moles of nitric acid. If you have, like, this is calcium hydroxide, right? So if we have like 3 into 10 raised to the power minus 4 moles, how many moles of nitric acid should it react with? Times it by 2, 6 into 10 raised to the power minus 4 moles. That's the moles of nitric acid. And once you have the moles of nitric acid, you can find the concentration, which is, we use N is equal to Cv, so we will divide here. So concentration is equal to moles over volume. The volume is in centimeter cube, so divide by 1,000 again. So you're going to get 0.025. So what do we get? 6 into 10 raised to the power minus 4 divided by 0.025, that gives me 0.024. So the concentration is 0.024. These were the moles and this was decimeter cube. So the formula is, the units are going to be mole per decimeter cube. And now let's just insert them. So in the first part, we just had to calculate the moles of calcium hydroxide, which is 3 into 10 raised to the power minus 4. Let's take this here. In the second one, obviously he'll ask us to calculate the moles of HNO3, which we've already done. And in the third bit, he will obviously ask us to calculate the concentration of HNO3, which again, we've already done. And now in the fourth step, he's saying calculate it in gram per decimeter cube. So how do you calculate this in gram per decimeter cube? Just convert these moles into grams. So let's write the answers as well. 6 into 10 raised to the power minus 4 and 0.024. So we just have to convert these 0.024 moles into grams. And how do you do that? You use the formula mass equals moles times molar mass, or mole times MR, which is wrong, but yeah, moles times MR, right? So what's the MR of HNO3? What's the molar mass? It's H is 1, nitrogen is 14, oxygen is 16, and you have 3 O's, times it by 3, that gives me 63. So mass we have to find, moles we already have, which is 0.024, and times it by 63. So we get 1.512, and this is gram per decimeter cube. And if you notice something, you're given the concentration up to 3 significant figures, 1, 2, 3. So if this is 3 significant figure, this should also be 3 significant figures. So I'll just write 1.51. Although this too is also acceptable in this particular question, but it's better to be question specific, right? And those of you who don't like these formulas, you can just do cross multiplication. Like if you've studied from me, we don't use formulas. So we say in 1 liter, you have these many moles. So if in 1 decimeter cube, or, I'll write or, right? Or in 1 decimeter cube, if you have 0.0150 moles, then in 0.020 decimeter cube, how many moles are you going to have? X or N, right? How did I find out 0.020? I just divided 20 over 1,000, right? So that will again give me, you have to still write the equation. So N is equal to 0.020 into 0.0150. and that's going to give me 3 into 10 raised to the power minus 4. Similarly, you could do all the same things here as well. So this is same for both. And in concentration, you know that if 1 mole here concentration, you have the moles and you have the volume, and the concentration is mole per volume. So you have the moles, which is 6 into 10 raised to the power minus 4, and volume is already given, which is 2.0. So this is again the same. Here, what is the difference? We find the molar mass. We know that 1 mole of HNO3 has right? 1 mole of HNO3 has how many grams? It has 63 grams. So if you have 0.024 moles, how many grams would it have? X is equal to 0.024 into 63. So it gives you the exact same value, right? So you could do either or, with using the formulas or without the formulas. Next, one sec, peeps. One sec. Where can I see the time? Okay. Next question says the equation for the reaction between methanoic acid and ethanol is shown. So if there's a reaction between the two, we know that this is our alcohol and that's our carboxylic acid. And alcohol and carboxylic acid are going to undergo a reaction called esterification. They're going to form an ester if you provide it with concentrated sulfuric acid and you heat it till 200 degrees Celsius, right? So these are the conditions. So how will you name it? The ethanol, since the alcohol loses the H, the name will change from ethanol to ethyl. Anything in organic chemistry, when it loses a hydrogen, it becomes the alkyl group. And methanoic acid, the IC and acid are going to go away and they're going to become ATE. So ethyl is going to be the alcohol's name and methanoic acid is going to go into methanoate, right? So the name is going to be ethyl methanoate. Now it says in the equation methanoic acid is represented by HCOOH. Name this type of formula. So that's basically the structural representation. It's the structural formula. Done. Write the empirical formula of methanoic acid. So what's the empirical formula of methanoic acid? It's the simplest whole number ratio of different atoms or ions in a compound. You have 1 carbon, you have 2 hydrogens, and you have 2 oxygens. So if we want to further simplify it, we can't. This is the most simplified way. You have 1 carbon, 2 hydrogens, and 2 oxygens. So you can't further simplify this into whole numbers. So that's the simplified way, CH2O, right? CH2O2, right? You have 2 oxygens. Done. Now it says name and draw the displayed formula of ester X. So ester X is ethyl methanoate. So let's draw it. What is the name? Ethyl methanoate. How do we draw it? Well, I can draw it directly, but you should first make ethanol or maybe the carboxylic acid. Usually it's the same thing, but it's just a convention to make the carboxylic acid first, but it does not make a difference whatsoever. Methanoic acid, we're going to make the structure of methanoic acid and we're going to make the structure of alcohol, and we're going to make sure that the functional groups, they face each other. So the alcohol loses the H and the carboxylic acid loses the OH, and a boom shakalaka, it gives you H2O, and these are going to bond together like this. Boom, boom, boom. That's the ester that forms. Just show the hydrogen, please. Done and dusted. It's a condensation reaction, yeah? That's why H2O is being formed. A small molecule is eliminated. Okay. The reaction is a reversible reaction and reaches an equilibrium when in a closed system. What do we mean by a closed system? In a closed system basically means that no reactant can enter or leave, no product can enter or leave, literally nothing can escape, right? So you could say a closed system means nothing can escape from it, or you could say no reactant or products, no reactants or products can escape, or you could say can enter or leave or whatnot. State 2 characteristics of equilibrium. Well, the first characteristic, because it's equilibrium literally means that the rate of forward reaction must be equal. Forward reaction is equal to the rate of reverse reaction, right? That's why we call it equilibrium. And and the full form of equilibrium is dynamic equilibrium, right? So the speed, the time it takes to go from reactants into products is the speed with which the products go back into the reactants. So the speed with which the reactants go into product is the speed with which the products go back into the reactants. That's why we say the rate of forward reaction equals the rate of backward reaction. And equilibrium means that the concentration of reactants and products are going to remain constant, right? The amounts of reactants and products are going to be constant. So the concentration, they're not equal. Please, if you write equal, 0 marks. They're not equal, but they're constant, right? For example, you have 100 molecules right here, and you have like let's suppose 7 molecules right here. So every time 2 of these molecules are going to convert into products, 2 of these will go back into the reactants. So the speed at which these will convert into products and these will convert back into the reactants are going to be equal, which we say the rate of forward and reaction equals the rate of reverse reaction. And the amounts are going to be constant now. It will always remain 100 and this will always remain 7, right? Unless you change conditions. So the concentration of reactants and products remain constant, are constant. Complete the diagram to show the effect, if any, on the concentration of X at equilibrium. So if you check this out, see, he's saying it's the enthalpy change is negative 2945, which means the forward is exo and the backward is endothermic. The forward is an exothermic reaction and the backward is an endothermic reaction. And now, what is my X? X is my ester right here. So he wants to see what the effect on the concentration of X is going to be. So if you decrease the temperature, decrease in temperature favors exothermic, and we know that exothermic is the forward reaction. So the equilibrium should shift to the right. Look at this. Exothermic is the forward reaction. So decrease in temperature favors exo, which is the forward reaction. Therefore, the position of the equilibrium shifts to right, and the concentration of your ester will actually increase. We say increases. Concentration of methanoic acid is decreased. If you decrease the amount of reactant, the system will want to oppose this change and increase the amount of reactant. How does the system increase the amount of reactant? By making more of this. And how will it make more of this? By shifting the position of equilibrium to the left. So once the position of equilibrium is shifted to the left, obviously more methanoic acid is going to form, right? Because you are decreasing it, the system will want to increase it. So X and H2O are going to be broken down back into these things. So what will happen to the concentration of X? It will obviously decrease. Both the concentration of methanoic acid and alcohol are decreased. Again, if you decrease the concentration of reactants, the system will want to increase the concentration of reactants by making more reactants. And how will you do that? By shifting the equilibrium to the left, the equilibrium position. So if the equilibrium position is shifted to the left, obviously these are going to break down again into the reactants, and therefore X should obviously decrease. So it decreases. This principle is called Le Chatelet's principle. You learn more on this in A levels. The catalyst is removed, but this is in your course. The catalyst is removed. The catalyst has no effect on equilibrium. So therefore, the concentration of X, it should have no effect. So it has no effect. Why? Because it does not affect, catalyst does not affect the position of equilibrium. Question 5. Question 5 says, butane and but1ene are colored as gases at room temperature and pressure. Okay. Butane is an alkane. And butene, because it's end with an E and E, we say it's an alkene. Now, suggest why but1ene diffuses quicker than butane. Why? Because but1ene is an alkene. What's the formula for butene? It's C4H8. CnH2n is the general formula, right? And alkanes, the number of hydrogens in alkanes are going to be twice the number of carbons plus 2. So C4H10. Obviously, but1ene is going to diffuse faster because it has a lower relative molecular mass. So relative molecular mass of but1ene is 56, and this is basically 58, right? So it has a lower, but1ene has a lower relative molecular mass. So it diffuses faster. Yeah? Butane is fatter compared to butene. Okay, identify the products formed when alkane, butane, undergoes combustion. So what are the products? Complete combustion, which means the products are going to be carbon dioxide and water and large amounts of energy. One molecule of butane reacts with one molecule of chlorine. It's an alkane reacting with a halogen. This is most probably going to be a substitution reaction. So C4H10 reacts with Cl2 in the presence of UV light. During this reaction, one hydrogen atom is going to substitute one hydrogen atom is going to be replaced by one chlorine atom. Obviously, when these two react, the chlorine is going to replace this, and the hydrogen that has been replaced is going to bond with the Cl and make HCl. So C4H9Cl plus HCl is going to form. Yeah, now it says steamy fumes of HCl are obtained. See, remember, this is not an acid, this is hydrogen chloride, not hydrochloric acid. Name the type of reaction which needs ultraviolet light. It's not talking about this. Many students will most probably think of writing substitution reaction. No, sir. It's saying what is the type of reaction which needs any reaction. It's not saying we are talking specifically about this. It's saying any reaction. Tell me a reaction which requires ultraviolet light. Such reactions are called photochemical reactions. Photo means light, right? So it requires light. Photochemical reactions. Done. State the purpose of ultraviolet light. What does the ultraviolet light do? It provides it with the activation energy. What is the activation energy? It's the minimum energy that reactant particles need to undergo successful collisions. So to provide the activation energy, because we know alkanes are generally unreactive, right? It says name the type of reaction which takes place when one atom, see, now it's talking about the substitution reaction, when one atom of chlorine replaces one atom of hydrogen. What is this type of reaction called? It's called substitution reaction. It says determine how many different structural isomers can form during this reaction. So if you check this out, you have C4H9Cl forming. C4H9Cl. I'm just talking about the Cl. So the Cl can come on the first carbon and the Cl can come on the second carbon. There can only be two structural isomers. Those of you who might say, sir, what about this? This would be the third carbon. Then no, sir, you are lacking in isomerism. This and this is the exact same thing. If you start, we always start numbering from the side where the functional group is the closest, right? So here, functional group is on the second, the functional group is on the second carbon, right here, the Cl. And here, because I'm going to start numbering from the side where the functional group is the closest, I'm going to start numbering from here, right? I'll give you an example right here. So here I'll start numbering from left to right, or from right to left. Why? Because the functional group is closer to the right. Here I'll start numbering from left to right because the functional group is closer to the left. So in both cases, this is 2-chlorobutane and that's again 2-chlorobutane. If you add a Cl here and add a Cl here, like in one case a Cl is here and in the other situation the Cl is here, both are the same things. This will also be known as chlorobutane, 1-chlorobutane, and this one, if the Cl is here, it will still be known as 1-chlorobutane because you start numbering from the side where the functional group is the closest, right? So let me just erase this up right here. Now it says when but1ene reacts with steam, two possible products form. Okay. What are the two possible products? Let's discuss that. But before we discuss I'm so tired. Before he discusses the two possible products, he says, identify the type of catalyst which is used in this reaction. So this is an alkene. It reacts with steam. Whenever alkenes react with steam, which is H2O gas, it needs what? It needs a temperature of 300 degrees Celsius, a pressure of 60 atmospheres or 6,000 kilopascals, and it needs a catalyst which is acidified aqueous phosphoric acid, and it gives you alcohol. So if it's a 4-carbon alkene, it's going to give you a 4-carbon alcohol as well. Now, identify the type of catalyst. The type of catalyst is acidified aqueous, AQUEOUS, aqueous phosphoric acid, right? H3PO4/H plus aqueous /H plus means acidified. We add H plus ions. Now, what are the two possible products? Make but1ene, please. If you make but1ene, what could happen is when you reacted with steam, two possibilities could take place. Either the OH would bond on the second carbon or the OH would bond on the first carbon. If the OH bonds on the first carbon, it will make a butan-1-ol with you guys. And if the OH bonds on the second carbon, it will make a butan-2-ol with you guys, right? So these are the two possible products. The first one is butan-1-ol, and the second one possibility is butan 2-ol, right? So let's draw this down. Meth at proper but 1-ol means that you show the OH on the first carbon, right? That's the OH. Please, you have in displayed formula show all the bonds, O bonded to H, all the bonds. And here again, 1, 2, 3, 4, and butan 2-ol. So the OH should now be on the second carbon. So O bonded to H. It's your choice. You can draw it above, below, whatever. So O bonded to the second carbon, right here, and just draw all the other hydrogen atoms. And please, I'm drawing it as single lines, but you have to mention H. Too many H's, yeah. But1-ene undergoes polymerization. State the type of, it's an alkene. Alkenes undergo addition polymerization. It's an addition polymerization. Draw part of the polymer molecule and show 3 repeat units. So but1-ene, oh, that's a good question. But1-ene, meth, eth, pro, but. That's but1-ene, right? Now, how do we polymerize but1-ene? Remember, everything should go around the carbon-carbon double bond, right? So but1-ene, if you draw the structure, it's something like this. Yeah. If I want to further simplify this for myself, I can say there are a carbon is bonded to 2 hydrogens, which is double bonded to a CH, which is bonded to 2 hydrogens, a carbon, and this carbon is bonded to 2 hydrogen, and this carbon is bonded to 3 hydrogen. Now everything should be around the double bond, right? Which essentially means that carbon, it has 2 hydrogens, great, good job. It is double bonded with this other carbon, which already has 1 hydrogen. Now what's going to happen? This CH2, CH3, they're going to go at the bottom of this carbon. Everything should be around these 2 carbons. In the straight chain, you should only have these 2 carbons. Everything else should be above and below them. So this already has 2 hydrogens. This has 1 hydrogen and 1 opening. This opening, instead of drawing a straight bond right here, this part is just going to go and get attached to its bond. You rotate it, right? You rotate it. Why do we do all of this? To go back successfully into its monomers. So you rotate it and add it here at the top or bottom. Now you could represent it as CH2, CH3, or you could add them together. So you could also represent them as C2H5. It's your choice. So you could go C2H5, or you could also go CH2, CH3, whichever one you like. So I'll just go C2H5 to avoid clutter. Yeah. So that's here, and that's like let's lower this bond. What a sec, let's lower this again to avoid a little clutter. So I'm going to duplicate this 3 times. Duplicate, copy. I'm going to paste it right here. I'm going to paste this right here again. And what's going to happen? Janab wala, the double bond is going to, let's move them all up. The double bond is going to break. The double bond is going to break, the double bond is going to break, the double bond is going to break, and new bonds are gonna form right here. Check this out. Bond forms, new bond forms, and these will be my connectivity bonds. So this will be bonded right here with this new molecule, which will be bonded right here, and these will be my connectivity bonds. Connectivity bonds are shown to tell the examiner that this can go on and on for thousands and thousands of molecules. This 5 doesn't look that good. Let me just change the 5. So that was a good question. Yeah, 5, 5, 5. You can also have written this C2H5 as CH2, CH3, but then that would cause a little clutter. And remember to bond this carbon with the carbon, not with the hydrogen first. That's it, I think, yeah. Full marks, yeah. Congratulations, peeps. We're officially done with the paper. Let me stop the recording and see you guys in the next bit. Bye, ciao.